Hello, all. So, in the previous class, we were discussing about maths in data science and machine learning, and I did started a topic that is linear algebra. Okay, so in linear algebra, I told your vectors and matrices are the important topics. Why? Because algebra deals with representation in terms of equations. Fine. So here linear equations can be formed and it can be written like ax plus by plus cz equal to d, where x, y, z are the variables and a, b, c are the coefficients, and d is again a constant certain value, okay, that we can say as an outcome. So why this thing is important? Because we are available with data, and this data is in a form of tabular arrangement. Okay, this is a tabular data. Okay, and we can say that these features or these columns as x1, x2, x3, x4, y be a target. Okay, so I want to draw a relationship between these independent and this dependent variable. For that, I can write like ax1 plus bx2 plus cx3 plus dx4 equal to y. Okay, where again the same thing, x1, x2, x3, x4 are the variables, independent variables, a b c d are the coefficients, y is a target outcome. Okay, so I can represent my data in this equation format. That is the reason we are dealing with linear algebra. And yesterday there's a question came to me that kindly differentiate between vectors and matrices, because you have represented them in a plot where there was a point 1 1 comma 2, and you have written it in the form of like this 1 comma 2. Okay, so this 1 comma 2, I told that it is a vector quantity. Okay, and I was saying that one dimensional, this is a vector, it's one dimension. Okay, and if I'm having a multi-dimensional data, like 2D, 3D representation, then it is a matrix. Okay, so vectors are used to locate a point. It's always been like 1D, like this, as you are seeing. A 1 comma 2, this is a vector. Okay, and can be written as 1 I cap plus 2 j cap. This is how I can write. It's a vector. However, if I do talk about the matrix, so for matrix, like here is your data. This is row number 1, this is row number 2, this is row number 3. So row 1, row 2, row 3, you have to consider these rows. Okay, you have to consider these rows, and you have to write them in a form of a matrix like this: x1, x2, x3, x4. Then row 1, row 2, row 3, row 4. Whatever be the values which are present in your data can be written here. So this is a matrix. And high order, okay, high order, fine. It can be like 2D, 3D, and it can be more, fine. And that will be later on converted to tensor. All right, so such kind of representation is a matrix representation. And this is your vector representation. Okay, let me share my entire screen and tell you more about these. Okay, so here, okay, here I mentioned the difference between a vector and a matrix. Vector is a one dimensional array of numbers. Okay, that's what you have made. One, 2, 3, 4. This is one dimensional array. Vector is a 1D array. Always remember. Okay. However, matrix is a two-dimensional array of numbers arranged in row and column both. Okay, fine. So like this: one, 2, 3, 4, 5, 6. That's what I said. High order. So this is 1D. This can be like 2D, 3D, even more. All right, that's the difference. Okay, and both vectors and the matrices are used in linear algebra. They do have various applications in data science, machine learning, and computational mathematics. Very important. And in the yesterday class only, I have shown you this vector space and how you can locate a point here by using the vectors, how you can perform the addition, how you can perform the subtraction, direction of a vector. We have already studied the properties also we have seen. Okay, in the previous class. Okay, fine. So this is what a linear function is. Okay, this yesterday also I told about the linear function. All right, ax plus by plus cz equal to d. This is a linear. This is linear. If I write a square x plus by plus cz equal to d, this is also linear, because a or a square, it doesn't matter. It's still a coefficient. It's a coefficient. So it's a linear equation. However, the things will change if I say ax square. If the variable degree is higher, then this is a quadratic equation. This is quadratic. Okay, so here the relationship is quadratic in nature between the variables. But we are currently talking about linear algebra, so we have to deal with the linear equations. Okay, so don't get confused. Here, examples are mentioned. Okay, that this function is a linear function, and this function is also a linear function. Alpha square. This is your coefficient ka square, so doesn't matter. Okay, still it's a linear. However, if I talk about f of x equal to x square, this is not linear. Okay, now we have more important concepts ahead, that is the dot product. Okay, this is the dot product. Okay, so we do calculate the dot product, that is also called as inner product. Okay, so the dot product we have performed between the vectors. Okay, for example, you have v vector and w vector, so you just write it as a dot. That means in case of physics also, I hope you have seen the dot product between the two vectors. If I talk about the topics like force and this displacement, okay, and there you have seen like your dot product a vector dot b vector as a b cos theta, where theta is the angle between these two vectors. Okay, theta is the angle between the vectors a and a vector b. Okay, so very important. These terms are also being present here in the maths with the vectors. So if I am available with, here you can see an example. I am taking the dot product. Okay, you can check it out. I already mentioned this formula. A vector dot b vector is equal to ab cos theta. Okay, so by seeing these, here it is. You can see 135. 135 is one of the vector. Okay, 135 is one of the vector. 246 is another vector. And here is the dot product. The resultant is 44. But you have to see the orientation, how these vectors are represented. One is in row and one is in column major. Okay, so this is what the property says. Fine. If I represent them according to the shape, it is having one row and three column. This one. And this is having three rows and one column. So since these are equal, then only we can perform the multiplication. It's according to the property. Okay, so how the multiplication goes on? 1 multiplied by 2 plus 3 multiplied by 4 plus 5 multiplied by 6. The answer is 44. This is how you do perform the dot product. All right. And here if I write v vector is equal to 1 I cap plus 2 j cap plus 3 k cap, and w vector is equal to 2 I cap plus 3 j cap plus 4 k cap. So v vector dot w vector is equal to, see here dot product between I dot I. Okay, I dot I is equal to 1. So between the same components it is 1, and between the different components it is 0. Why? Because as you know, the formula says that the dot product between the two vectors is ab cos theta, and if I and j I will consider, then the angle between both of them will be 90 degree. Why? Because both are perpendicular. So I j cos 90, cos 90 is 0. So obviously I dot j will be 0. However, I dot I, that means angle between both of them is 0. So cos 0 is 1. Okay, so that's why I'm mentioning here 1. And these are the unit vectors. So obviously the magnitude is 1 only. Okay, so the answer is 1 here. Okay, so if I do multiply these two, the result will be 1 into 2 is 2 plus 2 into 3 is 6 plus 3 into 4 is 12. So 6, 18, and 20. This is the answer, 20. If I want to represent them in a format like as we did in a matrix, so you have to write like this: 1, 2, 3. Okay, 1, 2, 3. This is how you have to write, and another you have to write like this: 2, 3, 4. 2, 3, 4. Then the kind of multiplication which you are seeing now, this one can be done. All right, so that's a dot product. Now we are having further more concepts in linear algebra, that is the normalization norms. Okay, they do measure the size or magnitude of a vector. That is the normalization. Okay, and we do have different types of normalization. The major normalizations are L1 and L2. Okay, L1 and L2. So L1 is Manhattan and L2 is Euclidean. Euclidean. Okay, so in normalization, as per the definition, it said I need to measure the size or the magnitude of a vector. And here is a formula for the normalization. Okay, that means vector to the power p divided to the vector to the power p, and then overall to the power 1 by p. This is the normalization formula. So what it is saying, that okay, this xi to the power p, and then overall just take the summation of all of these, it is then to the power 1 upon p. Okay, and commonly used norms are L1 and L2. L1 means the value of p is equal to 1. L2 means the value of p is equal to 2. So this is Manhattan, this is Euclidean. They are also been represented as in the form of a distances. Okay, fine. So let me again make you clear about these 2 points. Okay, that is a normalization norm, and it's very much important. Okay, norm or normalization. Normalization. All right. So in general, we are having two types of normalization: L1 and L2. It says that you have to take a vector. For example, you are available with a vector v, which is written as like okay, so 2i plus 3j. This is a vector you are available. So it's saying that you take the vector, okay, 2i plus 3j, and just take its coefficients. That means the coefficients are 2 and 3. These are the coefficients for the vector. Okay, these are the coefficients for the vector 2 and 3. You do one thing: add the coefficients, that will be 5. Add the coefficients, that will be 5. Okay, this is L1. This is L1. Adding the coefficients is said to be as L1. While in L2, you have to add the square of the coefficients. So 2 square plus 3 square, that is 9, it's 13. This is L2. Also, they told that the formula was add the coefficients add the coefficients, and you have to take to the power to the power how you did the addition. That means here I did the addition by taking 2 to the power 1, 3 to the power 1. So power here will be, in case of L1, that will be 1 by 1. Okay, so L1 means just adding the coefficients. That's it. However, if I do take the L2, it considers the square. Okay, that means 2 square, 3 square, and it will be 1 by 2 under root. That will be called as under root of 2 square plus 3 square. That will be under root of 13. This is L2. Alright, now one more thing. Let me simplify it more. Okay, here is what I make a plot. Okay, for example, this is origin. These are the 2 points. This is A, this is B. This coordinate is 0, comma 5. This coordinate is your 5 comma 0. So it's quite clear that the distance here is 5 and distance here is also 5. Okay, the distance here is also 5. All right, so here if I add, if I need to find the distance, what I need to do is, if this is O, so BO plus OA, this is what I need to do. BO, okay, BO plus OA. So 5 plus 5, that will be 10. This is Manhattan. Manhattan. Okay, this is Manhattan distance. It's been told to you that you need to find the distance of a vector. So if I just add the coefficients, that will be considered as a distance of a vector. However, if I calculate the shortest distance, this is the shortest distance. So that is equal to this square plus this square according to the Pythagoras theorem. You know about this thing. So 5 square plus 5 square ka under root. So that will be under root of 25 plus 25. That will be under root of 50. Okay, this will be the answer. This is also a distance, but it's a Euclidean distance. Euclidean distance. Okay, we do prefer Euclidean distance because Manhattan is like it's the longest, but we do prefer Euclidean distance. Okay, so this is L2 and this is L1. Okay, this is L1, this is L2. L1, it's also called as lasso. L2 is also called as ridge. Okay, ridge. We are going to see them in regression techniques. All right. So what I told so far, what I was teaching you related to the regularization. These are also regularization techniques. Okay, regularization techniques. So they were mentioned under a topic norm, or I would say normalization. Normalization. So regularization, normalization, all are same. Okay, all are same. Here the discussion went related to find the distance. Okay, to find the distance. And I told that there are two ways to find the distance. One is L1, one is L2. In L1, just add coefficients. Okay, just add the coefficients. In L2, I told that add square of the coefficients. Add square of the coefficients. That's what you have to do. And then to find exact distance, you have to take the under root of it. This is how L2 perform, and it's Euclidean, and this is Manhattan distance. Okay, and if you are available with a vector like 1I plus 2j, and if someone ask you that, kindly tell what is the normal form, what is the normal form of this vector. So what you will say, if someone asks you that, kindly give L1 normal form, so we'll say that okay, L1 now, so that is 1 plus 2, so that is 3. And now if you want to represent it in a normal form, so the answer is 1I plus 2j divided by 3, or it can be written as 1 upon 3I plus 2 upon 3j. This is the normal form. So just add the coefficient, divide. That's a normal form according to L1. Okay, fine. And if someone asks you about, again give a normal form of this, now use L2. So what you have to do, for the same vector, you have to perform 1 square plus 2 square, that is 1 plus 4, that is 5, and divide the vector by 5. Okay, so 1I plus 2j divided by 5, that is 1 by 5I plus 2 by 5j. This is L2. And the concept which I told you so far, they are very much important. IMP, normalization, regularization. Okay. Yes, Mr. Abhay, you can ask the question. Yes, Arshita Abhay, yes, you
So,
can ask the question. Yeah.
sir, in L2 for L2, I mean, in Euclidean distance, why are we not dividing by root 5 and why are we
You can
dividing by
do the root
pi?
5. Yeah, you can do it. You can put the root 5. Okay, root 5. No worries. Okay, you can do the root 5. All
Okay,
right.
sir.
Fine. So that's the Euclidean. Okay, you can divide with the root 5. Yeah, any other doubt? Please let me know. Yes, any other doubt? Please let me know. So these are the regularizations, L1 and L2. Okay, and very important because we are going to use them. Okay, in our our linear regression. Okay, we have to use them in our linear regression algorithm. Okay, where there is a cost function of linear regression, LR, and these regularization, these normalization techniques will be present in them in terms of penalty. Okay, so I'm just telling you right now. Okay, and we'll be seeing ahead about these things. Very important. These topics are regularization. And on the basis of this L1, L2, as I told the name, Lasso and Ridge. Okay, these are two separate regression algorithms. Okay, two separate regression algorithms, because we are adding penalty to the cost function of linear regression. So what is cost function, what is linear regression, what is penalty, I will be teaching ahead, but kindly remember these concepts which I have explained. That will be covered again there. Okay, so as the topic came now here, norm, so I explained you about these things. Okay, now there is one more kind of product that is called as the outer product. Okay, which is called as a cross product also. Outer product or a cross product. Okay, so this is outer product. Okay, here you can see. Okay, cross, not dot. It is cross. Okay, so I hope if I tell about the vectors related to the cross, so you do have an idea about, if I do take the cross product of the vectors, like if this is a vector, if I say 1I plus 2j, and this is another vector, that is 3i plus 4j. So if I take a vector cross b vector, it can be written as 1i plus 2j cross 3i plus 4j. Okay, and if I take the cross between them, so I cross I, okay, I cross I, this is 0. I cross I 0 because cross is taken as sine theta. It's taken as sine theta. And between the same vectors, angle is 0 and sine 0 is 0. Okay, so 1i into 3i is 0. Huh. 1i into 4j, 1i into 4j, यानी I cross j, I cross j, angle is 90, sin 90 is 1. But one more thing I need to put up here. I cross j is equal to k. K is perpendicular to both I and j. So it will be like something this. Okay, this is I, this is j, this is k. All three are perpendicular to each other. So I cross j, the direction will be this k. Okay, so 1i into 4j, 1 into 4 is 4, and I cross j is k. That is 4k cap. Then 2j into 3i, j cross I, j cross I. Here in case of if I cross j is k, then j cross I is minus k. Remember, these are vectors. Okay, so in vectors we have to take care of the direction. If I am saying that I cross j is k, then j cross I will be minus k. So here j, okay, 2j into 3i will be minus 6k, and 2j into 4j is 8 into 0, that will be 0. So the answer will be 4k minus 6k, that will be minus 2k. That is the answer of this cross product of the two vectors. Okay, and here in the example which you are seeing, again you are having the two vectors. Okay, so this is like n cross 1, 1 cross n. These are the dimensions of the vectors. All right. So n cross 1, 1 cross n. All right. So what you have to do is a1 into b1, a1, then see a1 into b1, then a1 into b2, then a1 into b3. Okay, this is your first row. Then a2 into b1, a2 into b2, then a2 into b3. This is how the matrix multiplication is performed. Okay, matrix multiplication. Okay, matrix multiplication. It's not like with just dot. Okay, dot, the scene was different. We just did a1, b1 plus a2, b2, and something. We just did that thing. Okay, you can see in the dot product. Okay, the scene was different with a dot. Here it was with a dot product. What you did is 1 into 2 plus 3 into 4 plus 5 into 6. Here the things are different with the outer product or the cross product. Okay, that means a1 into b1, then a2 into b2, a3 into b3. Okay, and correspondingly, first you have to do this into this, then this into this, then this into this first. This is your first row completed. Then a2 into this, second row completed, and a3 into this is the third row is completed. All right. If you want to check separately, let us suppose, acha, yeah, here also property. You have to match the property. See, one n cross 1 and 1 cross n. This should match. If this should match, then only the multiplication is performed. Okay, this should match, then only the multiplication is performed. And how it is performed? We took this one element and multiplied by this, and this. Then I took this element, then multiplied by them, and then so on. Okay, and if you want to check it separately, here you can. For example, this is your one of 1 2 3. Okay, like just rub it here. Okay, fine. And this is 1 2 3, and this is your 2 4 5. You want to perform cross product. Okay, what's the size of this matrix? This is 1 cross 3. This is the size. What is the size of this? It's 3 cross 1. Then it's 3 cross 1. Okay, so I can perform the multiplication because 3 and 3 both are same. I can perform the multiplication. How I'm going to do that? So what will be the result? The result will be 1 cross 1. This will be the result. 1 cross 1. Okay. Like 1 into 2, 1 into 2 plus 3, 2 into 4 plus 3 into 5. So that will be like a dot product here. Dot product. If I want to take a cross, then things will be certainly different. That will be like 1 into 2. Okay, 1 into 2. Okay, that is 2. Then 2 into 4 because there is nothing more present here. Okay, 1 into 2, that means it's over. Then 2 into 4. 2 into 4, that is 8. And then 3 into 5, 15. It will be like this cross product. This is the cross. This is the dot when you are going to take the sum, and this is the cross product. And what they have done here, the orientation was different. This is column major and this is row major. So every element present here is multiplied by every other element. Okay, and mentioned in a matrix. So the see the difference. This is n cross 1, 1 cross n. So the resultant matrix will be n cross n. And here it is. And here what we are doing? What we are doing here? This is 1 cross 3 and 3 cross 1. So the answer should be 1 cross 1. Answer should be 1 cross 1. Okay, and here this is giving 1 cross 1. If I say this is giving 1 cross 1, that means 2 plus 8 plus 15. So this is 23 and 25. That means one row and one column. This should be the answer. 25. One row and one column. This should be the answer. And if I change the orientation, that's what you have seen. So ये होगा like this. 1 2 3. Then this will be 2 4 5. Okay, and if I need to do the cross product, okay, so it will be like this into this. Okay, so this is your 3 cross 1 and this is 1 cross 3. So the resultant should be like 3 cross 3. Okay, so 1 into 2, 1 into 4, 1 into 5, 2 into 4, 2 into 2 is 4, 2 into 4 is 8, 2 into 5 is 10. Okay, and 3 into 6, 4, this is 12, and this is 15. This is your 3 cross 3 answer. This is cross product. All right, this is how we are going to find the cross. Outer product, actually. This is outer product. Okay, fine. Yes, anything you want to say, you can, please. Okay, 3 cross 3. We want this thing to be as like 3 cross 3. Okay, but here the resultant should be like 1 cross 1. So, yahi hai 1 cross 1, where I am having one row and one column. So, that is 25 only. One row and one column is 25. That's it. So, if you change the orientation, okay, if you change the orientation, see how the things got changed. Okay, so this is 3 cross 3 result. So, remember, outer product. Okay, so again, very important. Now, Data representation. Now let's talk something more about the data representation. Though I have already told you, when I show you data, okay, I did made the data, and this is how you represent the data in a vector notation. Data needs to be converted in arrays when you are going to feed it into the models. Okay, so we are not simply like giving data in actual format. We do convert them into arrays, and array are this notation only. Okay, so vector means 1D array, and matrix, that means 2D array. All right, so this is the vectors 3.51. Okay, converting data into the vectors. And for example, here is the data set. Here is the data set. Height, age, and the weight. Three features are there. So, considering the first row, you can represent it into this format. This is a vector format. Considering the first row, this is vector format. And height, age, and weight. Height, age, and weight. These three are, see, height, age, and the weight. These three are the three dimensions. My data is having three dimensions, and all are perpendicular to each other. Okay, all should be perpendicular to each other. So height, weight, and age all are perpendicular to each other. And this point 170, 24, 70, I can mark somewhere here. Okay, I can mark somewhere here. So this is 170, 24, 70. This is how I can represent. Okay, so in your data set, you will be available with many dimensions. And this is how I already explained you about those things. Okay, in my previous class. Okay, so this is how you perform the data representation. All right, so right now it is a vector, but if I consider rest of the rows also, it will be converted into a matrix. Okay, it will be like a matrix. Okay, so basically now we use NumPy as a library of Python, and NumPy is for multi-dimensional array. NumPy is for multi-dimensional array. This library. So that's the concept that you have to convert data into the arrays before feeding it to the models. Okay, because whatever be the operations, whatever be the maths we are going to apply, that are apply on array. Array is made up of numbers. Okay, so you have to work upon the numbers. All right, so that's the reason we have to transform the data into some notation. Okay, so here is the example related to it. Fine. Now let's talk about the matrices and its characteristics. Okay, so metrics are the collection of numbers arranged in row and column format, 2D. They are widely used in linear algebra to represent the coefficients of linear equation. Okay, so you will be having many linear equations. Okay, and with this data also, I can make a linear equations. Okay, for example, I am having the row number 1, 170, 24, 70. So I can write like this. Um, like you can, you are having height, weight, and the age, no? Okay, so you can write 170h plus 24 age plus 70 weight equal to something. Okay, equal to something. Okay, so linear equation. I can make system of linear equations based upon it. I just took this number as a as per my choice. Like this is A, B, and C. These are the coefficients. Okay, these are certainly the coefficients. Okay, so we can make many equations. No, one equation for this, one equation for this, one equation for this. So we can make many equations. Okay, so if I write this in a matrix format, it will be like height, age, weight, and 170, 24, 70, and then you can take 165, 45, 165, 45, and so on. All these things you can take, and this will be the target. Okay, this will be the target matrix, and you can perform system of linear equations to solve this and get the value of h, a, and w. Okay, you can find the value of h, a, and w by solving these equations. That's what they are saying. Okay, so to represent the coefficients of linear equation in a matrix format, we are using the concept of matrices. Very important. And uh, here, if we are having a matrix of rank 0, then it is just a scalar quantity. If you are having a matrix of rank 1, then it is a vector quantity. And if you are having n, that is 2D, 3D, then it's a matrix, and further high order, then it will be a tensor. I already told you. Okay, and these are the characteristics. The one which I was telling you. Tensor of rank 0, that means only magnitude. For example, if I write 2, this is a scalar quantity. Vector is a tensor of rank 1. That means if I write 2 I cap, okay, 2 I cap, again I added a dimension. This is a vector quantity. If I say 3 j cap also, vector quantity. Okay, of rank 1. And matrix rank 2. That means I have to write like this: 2, 3, 4, 5. This is a matrix. And now more than this, that will be exactly a tensor. So yesterday the question asked to me, sir, how you represent the tensors? Let me show you how I represent a tensor. Here is a diagram. Okay, let me show you how to represent a tensor. Okay, so okay, yeah, here it is. Okay, ये tensor है. So 1D tensor na, this is a vector. 2D is a matrix. ये 3D tensor है. This is 3D. That means adding one more dimension. So in vector na I am having only one dimension. Matrix I am having two dimensions. 3D obviously three dimensions. 4D is arranging 3D in height. So ये 3D, 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 3D all will be arranged in giving a height. Then it's 4D. Then one more you are going to add here, that it will be converted into 5D. Then one more back, then it will be converted into 6D. Okay, so these are the tensors. Okay, so vector matrix, this is 3D matrix. Okay, but now 4D, 5D, 6D, these are the tensors. All right, fine. So this is how you represent the tensors. Yesterday there was a question, sir, how to represent. So this is how you can represent a tensor. Okay, fine. Now let's get back to the your matrix thing. Okay, so in matrix, it's told that you have to solve system of linear equations. Why we are using matrix? To solve system of linear equations. Okay, and here you have to find value of coefficients. Okay, you have to find a value of coefficients. So you have to solve and find the value of coefficients. Okay, what should be the okay value of coefficient? Am I sure about that you are going to find a value of coefficients? See, if you are writing like this, ax1 plus bx2 plus cx3 equal to d1. If you are writing something like a1 x1 b1 x2 c1 x3 equal to d2. So how what you are talking about? What are you talking about? If I write like this, you will be organizing them na, in this way: a1, sorry, a b c, a1 b1 c1, this is equal to d1 d2, and this is x, this is y, this is z. So you're actually looking forward to find the value of x, y, and z. Okay, these you're looking forward to find the values of x, y, and z. I require one more equation. Okay, to find the value of variables x, y, and z. So matrix is used here. See, and why? Why again? I want to reason out this. Okay, let me reason out this. you are having data, not only data, you are having data set, and this data set is having many rows and many columns. If you want to solve a system of linear equation, so if you are available with 2x plus 3 is equal to 11, okay, so you can do one thing: 2x equal to 11 minus 3, 2x equal to 8, x equal to 4. This is easy. Now if you are having 2x plus 3y equal to 10, 3x plus 2y equal to 12. Now you are having x and y as two variable. So to solve these two variables, you require two equations. Okay, so let us suppose you are having a data right now with 2 3 and 3 2, such entries. This is x, this is y, and 10 and 12. This is how you are writing. Okay, this is how you are writing. And you need to find the value of x and y. So you have organized the coefficients here. These are the outcomes. So for two variable, you require two equation to solve. Okay. So here you will solve, you get some value of x and y. You get some value of x and y. Similarly, in our data set, we are having many rows and many columns. So you have to represent each and every row in this particular format only. Okay, this particular format. So we do make a data frame. Na? We do make a data frame using pandas. What it is? Pandas is a library in Python. We make a data frame. Data frame is row and column arrangement. Okay, that is your tabular format. Okay, it's a tabular format. Okay, we do this thing only in tabular format: row, column arrangement, and matrix, and whatever be the operations we have to do now, we do on this only, on data frames. Okay, ultimately I need to solve system of linear equations. Okay, so these variables x1, x2, x3, which are the features or the columns which are present in the data, and this target y, I need to identify the relationship, that how these independent variables is affecting this dependent variable. How it is affecting? What is the relationship between them? And this is what model do. This is what modeling is, to identify the relationship between the features, target and independent variables. This is what the model do. Okay, यही होता है machine learning data science में, to identify the pattern identification. That means how they are affecting this y, how they are impacting this y. यही होता है pattern recognition में. What is the relationship ultimately? That's what we have to do. Okay, so certainly right now we are dealing with the linear algebra. So linear equations are there. That means the degree of x, y, and z all is 1. That's why it is linear. The degree of all these three are 1. Okay, so it's linear. But it's not mandatory that it's always been 1. It can be a higher order also. Okay, then it will be not considered as a linear. It will be like polynomial. Then it will be polynomial. Because it's not mandatory that every time the relationship between the variables and the target is linear. No, it's not mandatory. It can be polynomial also. But right now we are dealing with this linear relationship. Okay, fine. So here we want to use the matrices, and that's one of the reason. Now one more thing, in matrices, I hope you have heard about this term rank, to identify the rank of a matrix. Okay, in engineering the students used to do identify the rank of a matrix. So if I ask you that, okay, this is a matrix, what is the rank of this matrix? What is the rank of this matrix? Actually, the rank of a matrix is defined in terms of linear independence. Linear independence. This is how the rank of a matrix is defined. Okay, so here in this particular case, I am having a matrix 1, 2, 3, 2, 2, 4, 6, 3. This is a matrix. And if I need to find what is the rank of this particular matrix, okay, so it's mentioned as 2. Why it's mentioned as 2? Because here the rank of a matrix A is 2 because it has only two linearly independent vectors. See, this is one of a vector, this is another vector, and I cannot represent vector 2 in terms of vector 1. So linearly independence is trying to identify that thing only. That can you represent a vector in form of another vector? Okay, so right now, if I do consider this matrix 1, 2, 3, 2, okay, let me make it on another sheet. The matrix is A, that is 1, 2, 3, 2, and another matrix is your 2, 4, 6, 3. Okay, so here it is 2, 4, 6, 3. So if I write the first as a vector, then it is written as, this is your row 1. It's been as a vector as 1 I cap plus 2 j cap plus 3 k cap plus 2, let me say, okay, I cap, j cap, okay, v cap. Okay, if I talk about row 2, this will be 2 I cap plus 4 j cap plus 6 k cap plus 3 v cap. If I take 2 common from row 2, it will be 1 I cap plus 2 j cap plus 3 k cap plus 3 by 2 v cap. If it would not be like 3 by 2, यदि वो नहीं होता, if it would not be like 3 by 2, if it is like 2, यदि if it is like 2, so this complete will become this vector by taking just 2 common. ये r2, it will complete become like r1 if this is not been 3 by 2, but at the moment we are having it as 3 by 2. So I can't represent r1 in terms of r2. I can't. So that means r1 and r2 are two independent vectors. Independent vectors. And since we are having two independent vectors, the rank of a matrix is 2. So we have to focus upon this thing, vectors. ये vectors है, ये vectors है. If I need to check whether I can represent this vector, one vector, into another vector notation. I need to check this thing. If I cannot represent them, as many as I cannot represent, that will be your that will be your the rank of a matrix. Very important concept. Rank of a matrix. That means how many independent vectors you are having. Okay, how many independent vectors you are having. This sets the correlation. This sets the correlation. Okay, if you are having dependent vectors, that means if any point is see here, if I am representing any point, if I am having dependent, so another point will be present in the same line, another point will also be present in the same line. So that means all these are correlated. And here, if I keep such kind of points in our data and give it to the model for training, okay, then model will not learn. Why? Because this is a correlated points. If I can identify this, now identification of the rest of the points is easy, because all are coming in a same line. All are in a same line. So these are co-linear actually. These are co-linear, and we are not going to support collinearity in the data. Neither correlation, neither collinearity. It should have to be least. Why? Because if I identify any of the point, rest of the points can be easily identified. So this is not at all learning or training of a model. We want model to struggle. We want model to do some tough work. Okay, so for that, pattern should have to be complex, not like a simple thing. Later on, this kind of model give overfitting, because model will capture all the collinear points and it will say that I am 99% accurate. But actually, in reality, the points are not been in a line. No? Points can be anywhere. In that case, the model will fail. Okay, so rank. That's what it means. That how many independent vectors you are having. So here you are having two independent vectors. They can't be represented in terms of any of them. So the rank is 2, and so on. This is how you can find the rank of a matrix. Also, and okay, so this is done. I hope you understood. Fine. And the next topic, that is the transpose of a matrix. So transpose is something like rows to columns and columns to row transformation. Okay, rows to columns and columns to rows transformation. Okay, this is transpose of a matrix. Okay, if we convert rows to columns and columns to rows, this is transpose of a matrix. Okay, fine. Just like, okay, if I do write like this, okay, here in the sheet. Okay, if this is your matrix 2, 5, 7, 10, so the transpose of this matrix will be, this is row, put it into a column. This is row, put it into a column. Okay, fine. Wait, here, put it into a column. That means 7, 10. So this is the transpose. Okay. One of the property of matrix, again important, that is used ahead for most of the tasks. That means like inverse and other things. Okay, so this is transpose. Okay, changing rows to columns and columns to rows. Transpose of a matrix. Now tell me, you understood the lecture or not? Yes. Okay, thank you, Daljit. Very active. Okay, Rohit sir. Okay.
50%, sir. It's a little bit hard time getting a rank and
Okay,
transform.
fine. So the thing is, you have to again revise the concepts. Okay, that's
Yeah.
not the tough concept. That are easy concepts related to the mass, linear algebra, matrices, and the vectors. Okay, so not that much tough. Okay, you can again go through the recordings.
Video and
All right.
okay.
So definitely you will be understanding what I taught. Okay, let me stop.